AP Chem video, and today we are going to be going over balancing chemical equations. So, if you have a reaction that says that one iron yields two irons, how would you make this equal? Well, what you do is you'd want to put a 2 in front of the iron that's just 1, right? Because then you can have two irons yields two irons. And in a reaction, the products and the reactants are always equal because mass is never gained or lost. So how do you think you'd make these two equal? Well, we see we have two hydrogens here, we have two oxygens, right? The subscript and the coefficient sort of means the same thing in a chemical reaction. So if there was a 2 here and the 2 here, it's going to mean the same thing. So there's two hydrogens, there's two oxygens, and here you have a molecule of H2O. So that molecule has two hydrogens and one oxygen. So these are pretty similar in, coefficients and amounts of atoms, but there's one difference. There's two oxygens here and there's one oxygen here. So here I labeled that. To go from this to this, you'd have to double the amount of oxygens. So how would you double the amount of oxygens? Well, you would put a 2 in front of H2O, right? You could, I know a lot of people would think that maybe you just want to put a 2 in front of the oxygen only, but if you have an entire molecule, you have to put the coefficient before the entire molecule because it comes together, right? So now you have 4 hydrogens because putting a coefficient is almost like putting a it's like almost like putting a coefficient and then doing the distributive property, right? So the 2 goes to the H2 and it goes to the O. So you have 2H2, so H2 times 2 is 4H, and then you have 2 oxygens. And here, remember, you have 2 hydrogens and 2 oxygens. So now your oxygens are equal, but now your problem is that you need more hydrogens on this side. And you need 2 times more hydrogens on the left side than the right side because it's 2 and then it goes to 4. So how would you do that? Well, you just put a 2 there. So 2H2, that's 4 hydrogens. O2, that's 2 oxygens. So now you have 4 hydrogens and 2 oxygens on your left side. And if you look at the molecule from before, we know that we have 4 hydrogens and 2 oxygens on the right side. So this is a completely equal and balanced equation. So now we have P4 plus Br2 yields PBr3. All right, so we can see that we have 4 P's on this side and 1 P on this side. So the first thing we want to do is just put a 4 there, right? So now we have 4 P's on both sides. So that's equal. But obviously, putting the 4 there messed up the BRs a lot. It was already kind of off, but now there's 12 BRs here because 4 BR3 is 4 times 3 BR, which is 12 BR. So now you have BR2 here and you have 12 BR on this side. So what can you add to BR2 to make it 12? What times 2 equals 12? Well, 6 times 2 equals 12. So P4 plus 6Br2 yields 4PBr3. And if you want to check this, you can see there's 4 P's here, 4 P's here, 12 BRs here, and 12 BRs here. So it's a completely balanced equation. So try doing this one by yourself and then pause the video and then come back if you didn't get the answer, or if you did get the answer, then cool. Okay, so we're going to go over this step by step. So Li3PO4 and plus NaBr yields Na3PO4 plus LiBr. Well, this might seem a little bit intimidating at first. The best way to do it is just to take it step by step. So you have 3 lithiums here and 1 lithium here. So what you want to do is you want to put a 3 there to make them equal, right? But putting the 3 there changed your amount of Br, right? It gave you 3 Br. So now you have 3 BRs on this side, and now you need to have 3 on this side. But to affect the BR, you also need to change the Na. So you need to put a 3 there. So you put a 3 there, so now there's 3 BRs, 3 BRs, but now there's 3 NAs. But look, you already have 3 NAs on this side, so you actually don't need to do anything. So we have 1 PO4 here, and we have 1 PO4 here. So sometimes when you do a little mistake or something, you can get your correct answer technically, but your answers will be basically double of the actual equation. So what do you notice about this equation? This was the same equation that we got as our first example, right? And this one is just this, but doubled. So what might have happened is you might have made a mistake or something like that and ended up getting all the answers double of the actual answer. But just know, in a case like this, if you get everything and it's divisible by a certain number, you can divide it by that number and sort of reduce the expression and get the right answer that way. Anyways, that's going to be it. Thank you guys.